solving inequalities. Inequalities are just these less than, greater than, less than or equal to, or greater than or equal to signs. So we can just treat them like we would treat a regular equation. Same properties apply. So like for this first one, if I'm solving for x, I'm just going to add that 7 to the other side. 5x is greater than, just copying the greater than sign instead of an equal sign. Negative 18 plus 7 is negative 11, and then I'm going to divide off my 5 and get x is greater than negative 11 over 5. I don't have to do anything special because I wasn't dividing by a negative sign there, so I'm just going to get x is greater than negative 11 over 5, and then next lesson we'll learn how to plot that on a number line. So then for this next one, I know there's some fractions there and they're a little freaky, but if I'm really just solving for x here, then I'm just going to add this 3/5 to the other side, no big deal. Right? So then I get negative 7x, copying down my inequality sign, is less than or equal to 7/5 plus 3/5. They already have a common denominator, so I can add their numerators. 7 plus 3 is 10. So 10/5 would end up being, what, 2? So I have negative 7x is less than or equal to 2. And now I'm just needing to get that x by itself, so I have this negative 7 being multiplied to it, so divide off that negative 7. Here's where we need to be so careful. Oh my gosh, when we are dividing or multiplying inequalities by negative signs or negative numbers, whatever, we have to remember to flip the inequality. So I need to make sure I flip this and say is greater than or equal to now instead of less than or equal to. So x is greater than or equal to negative 2/7. And make sure you're writing that division bar correctly.
Learning to solve equations empowers us. It empowers us to solve a variety of problems that we may encounter at different points in our life. So we're just going to run through a few examples that may or may not be as realistic to you as we would want, but it's okay, we need to learn. The first one involves traveling, and there's a really helpful equation for you to get in your mind. Distance equals rate times time. D equals RT. So I'm going to write that down because it is very useful. You will use it again. All right, let's go ahead and read this problem. 2 buses leave Seattle at the same time and travel in opposite directions. One bus averages 55 miles per hour and the other one averages 60 miles per hour. How much time until they are 345 miles apart? Now, I know you guys are super smart and many of you could just go, oh, I could probably sit and think about that. But remember, we're really trying to learn the process here. So even though the problem might be a teeny bit easier than a real life problem, let's learn how to work it out. So distance equals rate times time. I'm actually going to say bus 1, and I'll label it D equals RT. Distance 1 is 55 for the rate times the time. Then bus 2, D sub 2 for distance for the second bus equals rate times time. One thing we know is that the two distances that the buses have traveled has to add up to 345 miles. So distance 1, or D sub 1, plus D sub 2 equals 345. And then I'm going to use the substitution property of equality. D sub 1 is 55t plus D sub 2, 60t, equals 345. Remember, I've kept it an equation. Then I combine like terms. 115t equals 345. Divide out that 115, and we of course end up with t equals 3. I've solved the equation, but I haven't said and responded to the problem. So after 3 hours, the buses will be 345 miles apart.
So now that we've gotten through a distance equals rate times time problem, let's look at this next one about a triangle. Okay, so this one says the sides of a triangle are in a ratio 5, 7, 12. What is the length of each side if the total perimeter is 144 inches? Okay, anytime I have a problem where I have a shape involved, I definitely like to draw some sort of shape. So I have a triangle going on and the ratio of sides is 5, 7, and 12, and I'm just eyeballing where to put those. Now, those aren't the actual sides. We have this common multiplier that's involved here. So I'm just gonna make x my common multiplier. So it's gonna be 5x, 7x, and 12x. And then they tell me the fact that I know is that the perimeter is 144 inches. Well, the perimeter of any shape is just the sum of all of those sides, right? So say, okay, well, I've got the side 5x plus 7x plus 12x equals my perimeter of 144 inches. So when I start to do this math here, well, 5x plus 7x plus 12x, well, that's 24x. They're all like terms. 24x equals 144. Then I'm solving for x, so I divide by 24, divide by 24. X equals 6. Now, the question was, what are the lengths of each of the sides? So is 6 my answer? No, I want to know the length of each of my sides. So if one of my sides is 5x, when I plug in 6, it's going to be 5 times 6, so that's going to end up being 30. And then my other sides, if I plug in 6, 7 times 6 is going to be 42. And then I should totally be labeling these with inches, right? We need to make sure we're communicating appropriately. So 12x times 6 is 72, and then inches. Okay, so now if I want to say what my answer is, I can say the length of the sides are 30 inches, 42 inches, and 72 inches on my triangle.
All right, our next question is about 3 consecutive integers. I'm going to once again just really implore you, please do not sit and guess and check. The whole idea of this is to learn to use equations to solve a variety of problems. So here's just another variety. Consecutive integers, that means in order. So 3, 4, 5. 57, 58, 59. So we want to somehow get a variable. We don't want 3 different variables. We just want one variable to solve for. So let's just choose one variable and say the first number is n. Then the second number, how do I get to that? I just add 1. And then the third number, now how did I get to that from the first number? Oh, I would have had to go up 2. So let's write this down, identify your variable, and identify what it means. It says the sum is 399, so I need to add all 3 of those to 399. So we have the sum equals 399. Did you think about the fact that maybe we should have hugged those out? And we absolutely could, and I would want you to absolutely be thinking of it. But we know that we have the associative property of addition, so I can add in any order. So in this case, I technically don't need to hug them out. So I'll go ahead and combine like terms. I get 3n plus 3 equals 399. Finish solving that equation. And we get n equals 132. We haven't finished answering the question though, because it says what are the integers. So if n is 132, n plus 1 equals 133, and n plus 2 equals 134. I should always do a little quick check. Does that add to 399? Yes. We thought we'd kick it up a notch now. 4 consecutive odd integers. Well, odd integers, so like 7, 9, 11, 13. What's happening between each of those? I'm adding 2 to get to the next one. 7 plus 2 is 9, and so on. This time when I identify my variable, n can still be the first integer, but to get to the second integer that's odd, I'll have to add 2. So we have n, n plus 2, n plus 4, n plus 6. Remember, we are always going back to that first integer. Let's go ahead and add these up, equal to, what is it? 136. Combine like terms and solve. N equals 31, but then remember, first 4 consecutive odds. So 31, 33, 35, 37. And of course, a quick check, I can see that those do indeed add to 136.